Okay, Mr. Mulroy, welcome back to another specified practical.
Love it, sir, love it. Today we're looking at the reactivity of metals. Okay, and I've got a reactivity series down in front of us. So a lovely little rhyme for this. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So we've got please, potassium, stop. So
calling, calcium, me, magnesium, A, aluminium, careless, carbon, zebra, zinc, instead, iron, try, tin, learning, lead, how, hydrogen, copper.
Copper saves silver and gold. And gold.
You've made that very clear for us, sir.
Very clear. I thought I did, sir. Now, this reactivity series is a bit like a league table of how reactive an element is. Now, if I'm talking about reactivity, I'm looking at how easily will it react, okay? So how fast, how strong, how vigorous, these observations which show us that a reaction is happening.
I'm going to take a punt here, sir. I'm going to say potassium is the most reactive in that table.
It is, sir. Potassium's in the Champions League, okay?
Brilliant.
So he's right at the top, probably one of the most reactive elements in the world. We've then got gold, poor gold, down in Conference South. Love them. Not very reactive at all. And then in the middle, sort of zinc, iron, carbon, not that reactive, but they're not reactive, if that makes sense. Probably a bit like Cardiff City, just in the middle, okay? Now we're going to look at comparing the reactivity of four metals, okay? We're going to look at zinc, magnesium, iron, and copper. And we're going to look at this all in what we call a displacement reaction. Okay, now a displacement reaction is where a more reactive chemical comes along and it steals from a less reactive chemical. Okay, and we're going to model that using this well plate here. Okay, so I've set the well plate up. I've got iron, magnesium, copper, and iron. You'll notice that just to try and make this control variables and all that, I've got roughly the same amount of aluminium, copper, magnesium and iron. Obviously the iron's a bit more difficult because it comes in little powder-like filings. Now my prediction really is that I think magnesium is going to be my most reactive because it's highest up my reactivity series. And then going to have then zinc, then iron, and then finally poor old copper is going to be the least reactive. So I'm just going to move our reactivity series to the side. And we're going to look at this experiment. How am I knowing that a chemical reaction is going to be taking place? Well, first of all, quite an obvious one, a colour change. If any of my metals decide to change colour throughout this, I've got a reaction happening. If I get some fizzing, okay, a gas is being produced, something new is being formed, I've got a chemical reaction. If I form a precipitate is that lumpy solid, that's forming it. If it gets a bit smelly in you, it means that I've got a chemical reaction. And finally, if I see heat being produced. And we're going to look at this. If I think a chemical reaction is happening, I'm going to put a tick. And if I don't think one's going to be happening, I'm going to put a cross. Now over to these chemical reactions. I've set up a table of results. So I've got zinc, magnesium, copper and iron. You will notice that it goes zinc, magnesium, copper and iron in my well plate. And then I'm going to be reacting them with, first of all, zinc sulfate. I'm going to add zinc sulfate to each row.
Can you see that, sir?
You see that, sir?
Yes.
So this is a salt. Bit like that copper sulfate we've produced.
And
I've got
solutions,
magnesium sulfate. They are solutions.
Down a bit. Down. That's it. Lovely.
If I dried this out though, sir, I would get a lovely salt. And we'll remember this salt now.
Solution then.
Copper sulfate, that is that blue solution. Hopefully if you've been watching our series, you will have seen how to make this copper sulfate. I know you've been watching it, sir, haven't you? You love it.
Every night.
And then finally, iron sulfate. Okay, write down last one.
Cool.
We're going to add these chemicals in using a pipette. So I'm going to go one row at a time. If I think something's happening, I'll put a tick. If I think something isn't happening, I'll put a cross. Just remember now, in these reactions, they're all sulfates. The more reactive metal is going to steal that sulfate away. Okay? It's going to steal it because it wants it for itself because it's more reactive. So first one, zinc sulfate. I'm going to add it to all 4. And then I'm going to look at my table of results. So first one, zinc sulfate.
So does it matter how much you add?
Not really, sir. We're not that concerned. Just a nice little covering. Zinc sulfate, nothing has happened there. Cross.
I guess zinc can't really replace zinc,
No,
can it?
and we were going to talk about that at the end, weren't we, sir? So we've got zinc and zinc. We're going to have no reaction. We're now going to have zinc sulfate and magnesium. And perhaps we'll leave them. Just sort of settle, and then we'll come back to them. So we've got zinc and copper.
Now, I don't think copper will take the
I'm not
place of
sure
zinc.
either. And then finally, we've got zinc and iron. Now, you've seen how we're going to carry this experiment out. What myself and Sir will do now is we'll do the experiment, show you the results at the end, and then we'll talk through them. First thing then in terms of these results we can focus upon is magnesium. We got some bubbles, okay, so we're producing a gas there of some form. Now, magnesium, we looked at our reactivity series. Please stop calling me. Magnesium then is the 4th most reactive metal. So we should see a reaction fairly quickly. Now, if we took our time and we were really patient with this, we would begin to see other changes, okay?
And this is magnesium right by here, yeah?
Magnesium, row number 2. So the only one where magnesium is not reacting is the second one. We can notice here that beautiful blue solution we had before. We've got some black powder at the bottom. We know something must be happening. We've got some black powder in my iron sulfate. So it's beginning to form a reaction in there. No surprise, however, that nothing has happened in the magnesium row, okay? None of these are in the top league of that reactivity like magnesium, so they're not going to steal magnesium's sulfate. So if we pause this now, we will show you after we left this for sort of 10 minutes and then we looked at the results, and I'm going to draw them up in a results table. So our final, we're going to look at some results here. We've left this for a while. We're going to focus on zinc's column first. Okay, sir, so we're going to look.
So zinc is the first column, right?
Zinc first column, no surprise. Zinc and zinc sulfate, no reaction, because as you pointed out, sir, zinc can't replace zinc. Second well, nothing's happening again. Magnesium is higher up. Okay, please stop calling me a careless zebra. M is higher up than Z, so we're not going to have a reaction. If we look very closely now, the reaction with copper sulfate, the zinc which is underneath the blue solution is dark. That which is still outside is silvery. So we've had a reaction, a colour change. And finally, you'll have to look very carefully, but the zinc has gone darker underneath as well. If you compare the two, you can see.
Brilliant.
Now for magnesium, we've had a reaction in all of them apart from when it's reacting with itself. Magnesium, please stop calling me, most reactive metal there.
It's just going to displace all of the other metals.
Going to displace all. No surprise then, we've got a colour change there, a colour change there, and a colour change there. We've also got a few bubbles being formed, which is showing us there's a gas. So, copper, least reactive, right at the bottom. Conference South, as I said. No reactions. It's not going to be able to steal from anybody. Copper's a little weakling.
Is that why they use it in water pipes, sir?
I would say so, sir. Probably so it doesn't react with things.
Brilliant.
And then finally, iron. No reaction.
Bit of a mixed bag with iron.
Mixed bag. But look, sir, look at that lovely colour change. We've gone from silvery black to a lovely red colour. So we've had a reaction take place.
There's almost a pattern here, sir, whereby because iron is like the second one up. Is it the second one? No. So iron is the second from the bottom, so it only displaces one.
Yeah.
So it can only displace copper. I see how it works.
So you
now.
can only displace the one which is below you. Okay, so we can
zinc,
never have the underdog winning.
So I could also predict that zinc is going to displace 2. And let's have a look at our table results. Oh yeah, 2. And then magnesium with a 3. Poor old copper though.
Yeah, copper.
Mr. Mulroy, are there any improvements we can make on the displacement reaction?
First thing you'll notice, Mr. Timothy, is there's a lot of human error in there. Okay, when we were trying to spot those reactions, you'll notice perhaps right at the beginning we thought nothing was really happening, and then we went back to it, but we still weren't very sure if a reaction had taken place. So what we would do instead is use temperature change as the gauge of whether reaction is occurring. We'd use a fixed amount of time, perhaps 2 minutes, and we would observe temperature change using a digital thermometer. I'm trying to get away from that human error there. We would then record those results at the end of it and probably repeat as well, just to make sure we haven't made any mistakes. Hope you enjoyed that video.